the background of this really is that I started using mycorrhizal fungi in mine site rehab in 1981. And this continued in work I did in the tropics in Borneo in 1992. And it was this interest in mycorrhizal fungi and their behaviour, shall we say, in various climate and soil conditions, which when I finally retired, although I lost access to laboratories, I did continue to do some work on them. And the three factors which I looked at were firstly that these will be familiar to everybody, that the occurrence of fungal fruit bodies is erratic and seemingly unpredictable sometimes, that blooms appear at almost any time after rain, but may appear in one place and not in another, and that fruiting appeared more closely related to rainfall event type, that is the intensity and duration of rainfall, than the amount of rain. Now, this is all pretty basic stuff, and I'm sure you've all observed it. I guess from that point of view, this is fairly low-level science. It's more like natural history studies than science. And in fact, there isn't a single DNA analysis in the entire talk. So it's pretty basic science. But what's surprising about it is that so little has been done. And so in a way, this is groundbreaking, even though it's so simple. And this year has been a particularly interesting case, and hence this talk. The baseline data that I've got for the Cairns area, I've started collecting since 2015. And I started working on saprophytes at a place called Goombura Park. And I'll show you a map of where these are in a moment. And I looked at that for 4 years. And then the council, in its wisdom, went through the park, went through the rainforest and removed every log and branch laying on the ground. So that was the end of my saprophyte study. So I then moved to part of the Cairns Botanic Gardens, and I've studied there from 2019 to 2023. The area I've looked at is a remnant sandplain rainforest. It's only 0.8 of a hectare, less than 1 hectare. Consequently, you can get a pretty good look at everything that's there, and even under sparse numbers of fungi, it's pretty difficult to miss anything. It's such a small area, it's easy to study. And the results of that work in particular, I've published already in the Cairns Fungi Foragers. And it's in both of those as supplements. It's 2 parts to the paper, the first bit dealing with the rainfall, the second one dealing with substrates and supplementary observations. I didn't put it in a refereed journal because, as I said, it's pretty well basic natural history stuff, despite the fact that there's very little of it been done. And I've supplemented some of my observations with 40 years of local experience by Ray Palmer, a friend of mine who lives at Redlinch. I'll show you where that is on a map. And Ray has an excellent website. He's primarily a photographer rather than a fungal ecologist. Takes excellent photos, and I recommend his websites. Now, to give you a bit of background in the climate here before I start talking about Jasper, which was unusual, is that the long-term annual rainfall for Cairns is about 2,000 millimetres. And we get rain in every month, as you'll see a little later. But out of that 2,000 millimetres, about 3/4 of it, about 1,500 millimetres, arrives during the wet season. And the wet season officially is January, February and March, i.e. the summer. But in reality, 9 times out of 10, it actually starts in December. And it did with Tropical Cyclone Jasper just last December. The other features of this graph which I've shown you is, first of all, there are the long-term linear mean, which is this red line here, you'll notice is declining. It was almost exactly 1,500 millimetres back in 1943. And if you plot the wet season rainfalls up to last year, you find that there's a gradual decline. So the wet seasons are becoming slightly drier over a long period of time. Now, whether this is climate change or something else, I'm not sure, but it's of interest. The second thing is that although if you look at a 5-year linear mean, we basically follow the average, but we do get wet periods. For example, around 1974, there was a few years of above average wet season rainfall. And then a little bit later on, we get some very dry years, for example, in 2002. Excuse me, I've been fighting a throat infection for a couple of months and I'm struggling a bit. I thought it'd be all over by now, but unfortunately it isn't. Now, if we look at the distribution of rainfall by month, as I said, we do get rain in every month. And this is from 1943 to 2023, so it's long-term data. And it basically applies to all of tropical North Queensland, although this actual data set is from Cairns. As you can see, most of the rain falls around January, February, March. What is considered the locally is to be the wet season. But in reality, we get a fair bit in December. And most wet years, the break of rains, as we call it up here, which is the first significant rainfall event in any given wet season. It's known locally as the break of rains and usually occurs in December. Now, this shows you where things are. This is the main Bureau of Meteorology weather station at the Cairns airport. This is the Cairns Botanic Gardens located in here, which also carries a rain gauge. This is my house in Whitfield, and Redlynch is where Ray Palmer lives and where he does a lot of his fungus photography. Some of these other places are places where we do incidental fungal studies. So they're more sort of general collecting and observation. But these are our main study areas. And the first thing that I noted when I started looking at these locations is that the rainfall is actually quite variable, even over a short distance. And this may explain why you get crops of fungi sometimes in some places and not in others. All these sites here, the blue ones are Bureau of Meteorology sites, and the red ones are private ones, the Cairns Botanic Garden, my place at Whitfield and Ray's place at Redlynch. And if you look at these, you find that the racecourse, which is only 8.5 kilometres south of the airport, gets about 1,741 per year. But Coppola Dam, which is 14 kilometres southwest, gets nearly 2,500. So even though this whole area is within 28 k's radius, 28 k's diameter, it's within 14 k's of the airport, and yet there's significant variations in the amounts of rain that each of those suburbs gets. Now, the next thing I did was to look at the Cairns Airport data and the Cairns Botanic Gardens data, and I expected these to be pretty much the same because they're both parallel to the coast. It's pretty well parallel to the coast. And I thought most of our rain comes from the southeast, so I would, in the wet season at least, so I expected those to be similar. Then there's my place, and then there's Ray's at Redlynch. When I compared them for the first wet month of the year, which is January, this is from east to west, airport, Cairns Botanic Gardens, Whitfield and Redlynch. And then you can see that, in fact, in each of the years that I've got here, the amount of variation from one site to another is quite considerable. Although, for example, in 2019, Redlynch got roughly the same amount of rain as the airport, there was much less at the gardens and much more at my place. And similar sort of patterns occur every year. So there really is an uneven distribution of rainfall over relatively short areas, small areas. Now, the next thing I had available to me was a study which I did back at Goombura Park in 2017, where we had 22 days of rain non-stop. And we only got 325 mils or so over that period, but it was possible to study what fungi came up and in what numbers during 22 days of non-stop rain. And it wasn't patchy rain with heavy rain and then light rain. It was pretty well constant for 22 days. And I found, first of all, that the number of species is roughly linear with time and amount of rain there, number of species recorded there, the amount of rain here, and the same if you look at the number of sporocarps, the individual numbers of fungal fruiting bodies. Pretty well linear. So on the basis of that information, we can now look more closely at Tropical Cyclone Jasper. Now, these are a few local shots. This first one here shows the path that Jasper followed when it came in, and it went through just north of Cairns, the main part of it. Cairns is about here, and it walloped the whole area and flooded it. Massive flooding. This is in the Barron River catchment, the inland part of Cairns. This is in the CBD. These are some of the worst hit areas, just the roofs of houses sticking out, huge infrastructure damage, roads and bridges washed away, enormous amount of damage, costing billions, and some of it's still being rebuilt now. It's going to be a long time before some of this country becomes accessible again. So TC's Jasper was pretty serious. Now, just to remind you back here about the average rainfall, about 1,500 millimetres falls in the average wet season. Fair enough. To remind you of that. Now, if you look at the amount of rain we got in Tropical Cyclone Jasper, and in fact, in the whole of the wet season, we didn't get anything near, but just on the average. It wasn't a particularly wet year at all, despite all that damage that we saw. Some years, the total rainfall for the wet season is quite low, back in 2015, 16, 16, 17. In others, like 18, 19, we got above average rainfall, and this is for the whole wet season, December to March. So, although despite Tropical Cyclone Jasper and the damage it did, it wasn't above average rainfall. So what's going on? If we then look at the break of rains, which is, as I mentioned, the first significant rainfalls for the wet season, if we looked at the rainfall and the total number of fungal species, we start to see something odd. In this year, Tropical Cyclone Jasper, the break of rains dropped nearly 900 millimetres of rain with Cyclone Jasper. In most of the other years, we're getting only about 200 millimetres of rain. This is rainfall over 10, divided by 10, by the way, so that these scales can be matched. So on the average, in the break of rains, we might get about 200 mils, around that level. This year, we got a lot more, nearly 900 mils. So that seems to tell us that it's the amount of rain that we got in TC Jasper in the break of rains, and that caused a significant drop in number of fungal species. 2020, quite a few, sort of 18 species up here, 28 species. This was a poor year. The previous year here was pretty good, but this year was quite low in the numbers of species. Now, what I needed to look at then was an hourly rainfall figure to find out just how intense this rainfall was. Now, the Weather Bureau doesn't record it on a 1 hourly basis, or if they do, they don't make the data available. So the only thing I could do was get information from the Barron River pluviograph. Now, a pluviograph is a device which measures the depth of water in the Barron River at a given point. And as you can see here, this is the depth of water in the the river. It's from the gauge height in the river. If it's around about 5 metres, it's considered a minor flood. A moderate flood is about 8 and a bit. Major flood at 10, when the water depth gets up to about 10 metres. With Cyclone Jasper, it was 14 metres. So extremely deep, much deeper than even a major flood. And if you look at the pluviograph, you see how this happened. The cyclone started when we had 220 millimetres of rain fall in 4 hours. And the depth of the river went up from about 1 metre to just over 8 metres in a matter of just a few hours. And then it dropped a little and then rose again. And this is the major flood level at 10 metres. we got up to 14 metres. So the Barron River was really running very deep. And in fact, this is some pictures. This picture was taken a week before Cyclone Jasper. This was taken 2 days after. So we've gone from a trickle in the Barron Falls to an incredible flood in just a matter of a couple of days. And this is the significant item for the region. And if we go back to the break of rains in the Sandplains study area, which I mentioned earlier, was only 0.8 of a hectare. This is data from the previous years, which is from December 2019 to December 22. The average number of species observed in the break of rains in this 0.8 hectare was 22 species, and the number of sporocarps averages about 143. Now, this is saprophytes plus mycorrhizal, and that's significant, which we'll discuss in a moment. So the average in break of rains in this small area was about 22 species of macrofungi and about 143 being found. We then looked at with the break of rains with Tropical Cyclone Jasper. This is the days of the event, over the 7 days of the event. The number of species observed, the total was 10. The long-term average is 22. The number of sporocarps observed was 13. The long-term average was 143. So they were significantly down. And if you look at what types of fungi they were, there was really only 3 species, 3 genera, Entoloma, hygrocybe, and possibly Aracela. Well, that was hard to tell exactly what it was, but those 3 are mycorrhizal. All the rest are saprophytes. The mycorrhizal species really got a hammering. And so I went back and had a close look at the time of soil pH. Now, some of you may remember that back in 2018, I wrote a paper which was published in the Queensland Mycologist on the clay soils, looking at saturation of soils, how they became anoxic and acid and actually stopped the growth of fungi. Now, I looked at the same data here in this Sandplains study area, which is sandy soils, not clay. Tropical Cyclone Jasper commenced on the 13th of December. The long-term mean pH was around about 6.5 for the first 3 days. And this is now intense rain period. Then the pH in the soil began to drop and it became more acid. Cyclone Jasper stopped on the 18th, but the pH continued to drop, and it continued to drop down around for several days later. And having dropped, it then took a long time to build up to the average again, about 10 days. So there's been significant changes in soil pH because of the saturation. Now, if you then look at fruiting patterns of the fungi that did come up, there's a number of patterns, and I've published these in Cairns Fungi Forages, so those of you are familiar with it. There's 4 types of fruiting that I've recorded in this area, or 5 actually, the 5th one being a pressure-sensitive species. And these are a few species that pop up even before it starts to rain. They seem to detect the drop in barometric pressure, and it may be a day or even 2 days after they appear that the other fungi begin to appear, even if there's been a bit of rain in between. The first ones I'm calling the shotgun species, and that's this group here. As soon as you get good rains, they pop up immediately, put their heads up with usually the first 2 to 3 days of the raining period. And at the same time, or roughly around then, you get the ones that I call the shotgun approach for these. Every time you get a decent shower of rain through the entire wet season, they reappear, and tremellas on some of those species fall into that category. Then there's a group called the bell curve species. That's this group here. And it's a bell curve because when you first get some rains, they come up in very small numbers, then the numbers gradually increase, and then over time they gradually decrease until the end of the wet period. And that bell curve is fairly typical of some of the ones like Cortinarius. So, and then there's a few species, and these are often ascomycetes or coral fungi in particular, which seem to what I call wait-and-see species. It doesn't matter how much rain you get in here, they don't really stick their heads up until several days after there's been a period of rain. Some of the bell curve species have actually come and gone, and then right at the end of the wet period, they suddenly appear, what I call the wait-and-sees. And this is a little graph of those. Now, the break of rains is significant because you get pressure-sensitive species, the shotgun species, the opportunist species, and the beginning of the bell curve species all at once. And this is why that first rains of the season is so significant for so many fungal species, and why, as you all know, if you have a long dry spell and then suddenly you get some rain, you get quite a big flush of fungi, all other things being equal, which they really are. If we look at these in regards to Cyclone Jasper, we find that the mean number of species in this 0.8 hectare sandplain study area in normal years, so that's 2019 to 2023 data, the average, the mean number of pressure-sensitive species is 1, shotgun 11, opportunist 16, bell curve 13 species. After the break of rains for the 23-24 period, in other words, after Cyclone Jasper, no pressure sensitives, only 3 shotguns, 4 opportunists, and 2 bell curves. So the numbers are way down. Even if you look at the follow-up rainfalls, which in April, May were particularly wet in this year, but in previous years have tended to be only moderately wet or even dry like they were in 2020. But if you look at the actual rainfall, you find that the rainfalls in this year between January and May have been pretty average, or even February was pretty dry, and so was May. We had some good rains in March, but almost nothing new appeared. Nearly everything that we saw came up in the break of rains period. Now, there are distinct patterns in what appears and when it appears, and all this is published in Cairns Fungi Foragers. The normal sequence is you have a dry season, extended dry period, sometimes months, and then you get some heavy rainfall, and that's usually the break of rains. And you get many fungus species and individuals. And this is the break of rains fungi, the so-called first flush of fungi after the rain starts. If the rainfall is short-lived, you get the opportunist and you get the opportunist and shotgun species mainly. If there's a short dry period, but then it rains again, you get the same species as you did here, but smaller numbers of individuals. If the rainfall after a break of rains continues to be wet, the bell curve and wait-and-see species are the ones that become dominant. If there's a long dry period, but the substrates are still wet, for example, some types of wood, which absorb a lot of water, or around the edges of swamps and lakes, you get a few new species, but very few individuals of them. If you have a long dry period, immediately... Sorry, that's my phone. If you get a long dry period and then the substrates begin to dry out, the fruiting ceases until the following wet season. Now, this is exactly what happened post-Jasper. We had the heavy rainfalls in the break of rains of Jasper, and then 24 days with no rain at all, right through into the rest of December, beginning of January. So there was a long dry period and the substrates dried out. And when that happens, fruiting ceases until the next wet season. And that's exactly what's happened. Despite those fairly good follow-up rains, particularly in April, May, you get almost no fungi. So what are the observations in summary? And with Tropical Cyclone Jasper was intense, but had similar amounts of rain as on previous occasions, without any dramatic effect on the fungi that I've been able to detect. Also, the length of Tropical Cyclone Jasper event was about average. The follow-up rains were about average or even just a little wetter, and the saturation of soil with resultant increase in acidity probably impacted the mycorrhizal species in particular, and it certainly has in other locations on other occasions. I found that delicate species, such as Phylloboletus, Lycocapronus and Mycena, were simply pulverised, and Ray Palmer found exactly the same thing at his place. They were literally smashed to bits, and it was difficult to find any of them. They were there, but they were crunched up, and there was a lot of species which grew up on logs and things that would come up maybe a millimetre or two and then literally be pulverised. A lot of them looked like soil fungi, looked like they'd been trodden on. They were so mashed. And so despite the follow-up rains in January to May, fungal fruiting and spore set for 23-24 was very poor, and it wasn't followed up with the later part of the wet season. So effectively, we've lost the spore cohort for this particular area in Cairns for this last wet season. Now, observations in some of the inland areas did not show the same degree of fungal reduction. There's some areas to the west of here which are up on hillsides or a little bit further inland in around Muir, if you know the area. They got a lot of rain, but they didn't get anywhere near the intensity of rain that we got here in some of the areas that were severely flooded. And in those places, fruiting of fungi was almost exactly the same as it normally occurs in every year. But this is only observational data. I don't have any statistics. It was observed by other people, and I couldn't get to most of it because the roads were closed for over a week, and so I missed it. So I've concluded that from this, that the critical impact of Jasper around Cairns was not caused by the amount of rain or its duration, but by its intensity. Excuse me. The break of rains is again shown as the most significant event. And if break of rains and intense rainfall coincide, you may lose that fungal cohort for that year. That might be a significant loss, particularly in certain areas. And that loss seems to affect all the fruiting types more or less equally. And so the saturation of both sandy and clay soils with a resultant increase in acidity may significantly impact mycorrhizal species. So if we, in the future, had a series of these extremely wet breaks of rain, which is quite likely with impending climate change, there could be changes in mycorrhizal species to the point where they'll begin to affect their plant flora that are associated with them. Now, are these observations true elsewhere? I have no idea. I have no data. I don't know of anybody else who's collecting similar data. And we need people to collect more information on these sorts of things. You don't require much equipment. A rain gauge, maybe a pH meter, but you can buy one of those at Bunnings for $20 and do some studies of this type. It's pretty basic. High school kids can do it. Even primary school kids can probably do it. But it's not being done. There seems to be almost no information except for mine. I'd like to get some other people involved in it. If you want to discuss that or get more information or copies of what I've done, there's my email address. Feel free to contact me. And that's basically all I've got to say in a nutshell, short and sweet. Any questions?
Thank you, Barry. I was receiving a round of applause there. Can you hear me?
Yes, I can hear you.
Oh, very good. Were there any questions? No, I think we're all good. And thank you so much, Barry, for sharing that wealth of information and that amazing data with us.
That's all right.
Appreciate it.
It's all pretty basic. There's no high science there, but it'd be easy for any of us to collect. You just need the enthusiasm.
Yes, indeed. All right, I'm going to stop your sharing there now, and I'm going to hand over to our next speaker.
Okay, no worries.
Which is Fran Gard. All right. Thank
Oh,
you, Barry. I appreciate that.
okay, no worries. Hi, Fran.
Thank you. Thank you.
Okay. Can everybody hear me? Or can anybody hear me?
Yes, I can hear you, Fran.
Good. Okay. I'm just reporting on a couple of specimens that we found on the Linda Garrett foray a couple of weeks ago, or a month ago it is now. And these are just ones that I was particularly interested in and got to take home to examine further. So the first one is Mycena cystidiosa, and I was fascinated by this because I had had some communication with a mycologist in Sydney just the previous week and had boldly said, we don't get that one in Queensland. And then lo and behold, we found it in Linda Garrett. And it's called the tall Mycena, and that's because the fruit body, the stems of these little mushrooms can be anything from 60 to 200 millimeters long. So that's a very long stem for a little Mycena. And next, thanks. Oh, just the photo on the right is actually a low power microscopic photo of the gill of this Mycena, showing the cystidia, which are on both the faces of the gill and also, I haven't shown it there, but they're also on the edge as well. So next. One of the main things that you see when you find this thing are these white mycelial or rhizomorph threads all over the substrate, and this happened to be a very mossy log, and they were just growing in a tangle all over it. And then there were only a few fruit bodies there, but later we found it again. This one had been a little bit nibbled, but you can see that there is a large basal mat of hairs, the white hairs there at the base of that stem. Next. So that's just showing these little brown fruit bodies. They're darker at the center and paler around the margin. And that's the whole collection. The base you can see is quite hairy, and the stems are long and thin. Now, the interesting thing next is, oh, that doesn't show up very well. That's a map of Australia, actually. It's a bit blown out. I'm amazed. Anyway, the two dots at the top are actually in Queensland, and all the rest are in New South Wales, Victoria, and Tasmania, apart from a couple over in WA. And there are over 2,000 records of it in the Atlas of Living Australia, but only 2 of them are from Queensland, and ours is the second. And the photo on the left is not my photo, but it shows how extremely long the stems can be. Okay. And this is just a higher powered magnification of the cystidia on the gills, which were really quite beautiful. And the spores, unusually, I think, for Mycenas, they're amyloid, which means they turn a bluish colour when you put them in the iodine solution meltzers. But one of the fascinating things for me, because I'm interested in rhizomorphs through my marasmia studies, is that the tips of the rhizome, or those white threads, are like little tiny caps. Now, that's a very highly magnified picture of one of the tips of the rhizomorphs, and that's exactly how they appear. And that is very different. Next one. From other rhizomorphs. The one on the left is one that I found of Marasmius crinosequi in Mary Cairncross, and it's like a little match head. on the tip of the rhizomorph, and it's quite microscopic. You can't really see that until you magnify it. Then I compared that with the rhizomorphs of Crinipellus, which also occurs in Mary Cairncross, and it's just hairs. Crinipellus have a lot of hairs in a lot of places, including on the ends of the rhizomorphs. When we were up north Queensland looking for Marasmius up there, we found these ones with like little arrowheads, and they were actually visible to the naked eye. So they're much bigger than these others, even though there they look smaller, but they are bigger and can be seen in good light. And at the time, though, I saw them and they were on the end of black rhizomorphs, and I thought, oh yes, this must be what Crinosequi or Marasmius looks like. But in fact, looking back at it, I think now that they may well have been a Gymnopus species, because the rhizomorphs were thicker and shorter and straighter, and so a different one. And then this one down here is the Mycenas istidiosa. So it appears that they can be specific in shape perhaps for species, but certainly for different genera, which I found was all quite interesting. And then the scientist who first described the Mycenas istidiosa rhizomorph tip did another paper looking at, and that was from Sydney, and he was also looking at, on the left, what he called Marasmius crinosequi rhizomorph tips, which when he looked at them with a scanning electron micrograph, were just came to an end, and they were all a bunch of hyphae that had no particular shape to the tip. I have a feeling that he was probably looking at something else, because this was done back in 1992, before he had access to DNA work. And so he just simply said he collected Marasmius crinosequi rhizomorphs, and that's what the ends look like. But I think that he may have actually mistaken that for some, and that's yet another form and perhaps a different species or even a different genus. Okay, next. The other two specimens that I took home were amanitas. And in the end, I wasn't quite sure if they were the same species or not. And I've only called this one a Aph vaginata. It was a beautiful specimen with a cap that was a smooth brown cap. It had just a tiny little patch of white veil remnant on the top of it, and then it had the outer half was the sulcate striate appearance, which you get in the vaginata type amanitas, and this great big sock-like or sac-like vulva, no annulus remnants, and a beautiful patterning, like they called it zebra patterning on the stem. And when I looked at the spores, they were inamyloid, so they didn't change blue, and they were globose or subglobose. So when I looked up Amanita vaginata, I believe it's actually described from overseas. I don't think it's an Australian species, so I don't know what this one is. Anyway, I then looked at the next one, which in some ways was quite similar. It was a very young one, so its stem hadn't expanded as long, and the cap hadn't opened, and unfortunately I could not find any spores because it was a little bit too young. It had the same outer sulcate striate appearance on the cap, and a patch, a larger patch on this one, you can see it over here, of the remnants from the veil, the universal veil, and a great big sac-like vulva. But no patterning on the stem. There was no annulus either. The pictures don't show that very clearly, but there certainly wasn't any annulus. Was it just a young one of the same thing and hadn't yet developed its patterning, or something else? I couldn't find any spores even when I looked under the microscope. So that one's a little bit of a mystery. And that, said Fred, is that. The question is, what magnification for those cystidia? In actual fact, when I looked at them under my dissecting microscope, just at 30 times total, you could see the most beautiful crystal-like appearance on the gill edge. It was just really beautiful. Unfortunately, I couldn't photograph that. So the photo there is 20 or 40 times. That's 200 to 400 times. That is, yeah. And the tip of the rhizomorph is also about at least 100 times.